Hi everybody. I wanted to show you how to work a two-body problem like the ones we were doing in class. And I want to try to do this in a way that I can show you what's general and what is specific to this individual problem. So the problem says, find the mass of a rocket that accelerates at a rate of 1.5 meters per second squared as it launches itself from Earth with a thrust force of 80,000 newtons. If it's a problem that uses Newton's second law like this, you know you're going to need to draw a free body diagram. So that's where you start. I draw everything as squares, so there's your square-looking rocket. We know that it's accelerating upwards with a thrust force of 80,000 newtons. So there's the thrust force. We can label it as 80,000 newtons. There we are. And then we also have another force acting down. If you're on Earth, you know that there's going to be a gravitational force. So we draw a gravitational force. And if it's accelerating upwards, we know that the thrust force is bigger than the gravitational force. So remember that the net force, that is the larger force, always needs to be in the direction of the acceleration. So in this case, we have the weight that's pushing it down. Now the weight, which you can call, in class I was calling it F of g, it just means the force of gravity. That's equal to mass times the acceleration of gravity, so it's equal to mg. It's always equal to mg. And for good measure, we can draw in the velocity. The velocity arrow is here, because we know it's moving upwards. That helps with friction problems, because we know that in a friction problem, the direction of friction is always opposite the direction of velocity. So the next step is to set up our Newton's second law equation, which we're going to do down here. We start with F equals ma. There it is. So we have F equals ma. Now that's the net force. And the net force, in this case, is going to be the 80,000 newtons minus mg, and that's equal to ma. Now this is the key step. Now keep in mind, this isn't always going to be 80,000 going up. It's not always going to be mg going down. Sometimes the forces are going to move side to side. Sometimes they're going to go up a ramp or down a ramp. In this case, we only have the forces acting in a vertical line, where one's going up and one's going down. So this step right here, this can be flexible in different problems. Sometimes you'll have both forces in the same direction, in which case you add them, and sometimes you'll only have one force. But in this case, we've got two forces. We know the acceleration of gravity is always 9.8. We know in this specific problem that the acceleration, remember, is 1.5. So we can set that up. We can say 80,000 minus mass times 9.8. Acceleration of gravity is always 9.8. Is equal to mass times 1.5. We collect like terms, so we get 80,000 is equal to mass times 9.8 plus mass times 1.5, which gives us 80,000 is equal to mass times 11.3. So if we want to find out the mass we need to divide, we take 80,000 divided by 11.3, not 1.3, and that gives us 7079. 7079 kilograms. And there we have it.